6.3 is the rational numbers. So recall, what are the rational numbers? Fractions? Okay. Not quite decimals. I think you're thinking about real numbers. So fractions. Okay? How can I write that in step builder notation? So the set of A over B such that what? It's in your notes.
Such that A and B are integers and B cannot equal 0.
Good. A and B are integers. And B does not equal 0. I can never have 0 in the denominator, right? So somebody said that this is fractions, right? And I usually denote the rational numbers by Q. Q with that. It's a fancy math Q. So what are some numbers that are in here? Is 0.5 in here? Yes, because 0.5 can be written as a fraction, right? 0.5 is 1/2. Is 2 in here? Yes, because 2 is 2 over 1, right? Is pi in here? No, because pi is 3.1415, and it doesn't repeat, so I cannot write it as a fraction. So pi is not a rational number. But 1/2, 1/4, 3/4, 100, 1,000, whatever. Anything that can be written as a fraction is in there, right? The numerator is a whole number, can be 0, can be negative. The denominator cannot be 0, but it's an integer. Okay. So note, what's the numerator? Oh man. Which one's the numerator? What is it? The top is the numerator, right? What's the bottom of the fraction called? Okay, just some vocab, right? So we can all be talking about the same thing here. Okay, so the top of a fraction is the numerator. The bottom of the fraction is the denominator. Okay. So equality of rational numbers. So this, we're going to take it as a definition. So two rational numbers are equal if what? How do you know if two fractions are equal? So if the denominator is the same. Are those equal? No. So if you have an idea and you can come up with one counterexample. What's everybody's favorite thing to do with fractions? What? Oh, yeah. So you can write them as like little pizzas if you're talking about what fractions are. Yes. So everybody's favorite thing to do is to cross multiply. If you ever have fractions, the first thing people say is cross multiply, no matter what. Okay, so cross multiply. So this is if AD equals CB. That's how we know if two fractions are equal. Well, let's do an example. So are these equal? 1/2 and 2/4. Are they equal? Yeah, you can just see that, right? 2/4, if you simplify that, is 1/2. But if we go from the definition, 1/2 equals 2/4. This equals is kind of a question mark, right? That's what we're testing. In order to test that, we cross multiply. So we have 1 times 4. Does that equal 2 times 2? Yes, so they're equal. Right. This is just putting that idea into letters so that you can apply it to any fractions, right? This you've been doing for a long time, right? Let's do another example. 1/2 and 3/4. Are those two equal? Well, if we're not sure, let's do 1/2. Does that equal 3/4? Well, we're going to cross multiply and see. So we have 1 times 4 equals 3 times 2. So we have 4 equals 6. No. Not equal. Okay. Okay, let's talk about canceling common factors. So I have A times C over B times C. What does that equal? What is it? A over B. How did you get that, Shelby?
Just cancel the C's.
And why can you do that?
Because they're the same.
Because they're the same. Because C over C equals 1, right? Fine. Take 1 away anytime you want to. Multiply by 1 anytime you want to. Add 0 anytime you want to. We're taking 1 away. That's fine, right? We're canceling out 1. So let's do an example. Simplify 48 over 72. So let's write out the prime factorization. 48 equals 2 times what? Times 24? 24 is 2 times what? 12. 12 is 2 times what? 6. 6 is 2 times what? 3. Okay. Prime factorization. Okay, what's the prime factorization for 72? 72 is 2 times what? 36? 36 is 2 times what? 18. 18 is 2 times what? 9? Okay, 9 is 3 times what? 3. Okay, so now I'm going to cross out all my common factors. Like 2 over 2 equals 1. I don't need to write 1 times something, right? 2 over 2 is 1. 2 over 2 is 1. 3 over 3 is 1. Right? Those are my common factors. I can cancel them because it equals 1. I don't need to write 1 times 1 times 1 times 2 over 3 times 1, right? Let's not waste the ink. So this equals 2 over 3. So is that clear? You can write out the prime factorization and then cancel common terms. Okay? B. adding and subtracting rational numbers. So adding and subtracting rationals. Okay, so A over B plus C over D. So when can I add fractions? When the denominator is the same, when the bottom number is the same. So how can I make these two denominators the same? Yes, good. So I need a common denominator, right? So remember, so in order to multiply fractions, you multiply numerator times numerator, denominator times denominator. So I'm going to multiply this times a factor of 1. D over D is 1, right? BD is going to be my common denominator. I'm multiplying these two denominators. Plus C over D. What do I multiply D by to get BD? B, right? So I need to multiply by a factor of 1. Multiply by a factor of 1 anytime you want to, right? Okay, so when I multiply fractions, I multiply numerator times numerator and denominator times denominator. Okay, so here I have AD over BD plus CB over DB. Okay. Then once I have the common denominator, what do I do? What?
Don't you add the numerators and then simplify?
Add the numerators. What happens to the denominator? Do I add the denominator? What do I do? Some people say no. So I add the numerators and I keep the denominator the same, right? So I think in the book it just has these two, but this is the reason why, right? So AB plus CD equals this, but this is all the rationale for it. Okay, let's do an example. So this, I wrote this for adding, but this could be subtraction as well, right? Okay, so add or subtract the following. So this is example 4. This was example 3. So example 4, add 1/2 plus 1/2. Okay, I already have a common denominator, right? So I'm going to add the numerators. Keep the denominator the same, add the numerators. 2 over 2, I can simplify, right? I can cancel out my common factors. 2 over 2 equals what? 1. Okay. How about 1/2 plus 1/3? So we can either go straight from this formula to here, or we can do the reasoning behind it as well. Let's do the reasoning behind it. And then if we just want to jump to the formula, we can. I don't really like to remember formulas like this because I think it kind of makes it harder. If you know that in order to add and subtract fractions, you have to have a common denominator. Then when you add, you have the common denominator, you combine the numerator. This I don't know. It seems like a lot. What do you guys think? Okay, so I'm going to multiply. The common denominator is 6. So I'm going to multiply the first fraction by 3 over 3 because I'm trying to make the denominator 6. For 1/3, what do I multiply 3 by to get 6? 2, and I need to multiply by a factor of 1, right? So then when I multiply fractions, I do numerator times numerator, denominator times denominator. So I do that for both. So 1 times 3 is 3, 2 times 3 is 6. Then for the other fraction, I multiply numerators. 1 times 2 is 2, and for the denominators, 3 times 2 is 6. Okay, I have a common denominator, right? So now I can combine my numerators. 3 plus 2 is 5, so I get 5 over 6. Okay, so remember, this will be on the test. You're only going to have a calculator that can do multiplication, division. It won't be able to do fractions. I think we have time for one more, though. Oh, we still have 3 minutes. Huh? I'm going to give you a calculator. I don't care what calculator you have. You get to use my calculator. Dollar store calculator. Okay, so 6, let's do another. 4 over 7 minus 3 over 2. Okay, you guys try to do this one on your own. I'm going to write my answer. You write yours. If you want to remember that formula, you can. I'm going to write out all the steps, though. Not surprisingly, things like adding and subtracting fractions are people's biggest issue in classes like calculus, right? These are things that you guys have been doing forever, but for some reason people struggle with. So check my work. I can't add. So did I get it right? Okay, so all the stuff we did today can be on the test. I'm going to make homework for the stuff that we covered.